Hello. In this video, I will be discussing examples of one input variable allocation. So the video is the third video on chapter 3 when we go through some practices. So let's say that we have a production function that is y equals 65.54, and so that's the fixed cost, right? Plus 1.084x minus 0.03x squared. So if a question is asked, what is the optimum input that will be needed to maximize production, because we only have production here, the key equation is this one, where value marginal product equals price, okay? And so the value marginal product is the same as marginal revenue, and X is marginal cost. So it's no different from the idea of marginal revenue equals marginal cost. It's the same thing. What is value marginal product? It's price, right, time output, okay? So that's error. Value marginal product is price time marginal physical product. And so it's usually we don't use the 2P, just a value marginal product, okay? We don't typically say value marginal physical product, okay? So, sorry, times marginal physical product. And so given that, then marginal physical product here, okay? And so that, of course, is equal X. And so I take marginal physical product equals X divided by PY. Okay. Okay, because to get this, indeed, from this value here, what I have is value is PY time marginal physical product equals PX. So marginal physical product equals PX divided by PY. Okay, okay, let's get it out of here. So we are given two pieces of information. Okay, one is at optimum, the price is 0.25, and the price of X and the price of Y is 2.5. Okay, and so that's information that we use to determine the optimum. And so, but primarily, if you want to determine the optimum, we need to compute the marginal physical product first, okay, because we don't know it yet. So the marginal physical product is then the derivative, okay, the first derivative of Y with respect to X. So when you are doing your homework and your exam, please don't forget to add this. So some of you forgot to add what you are computing, okay? So specify what you are computing and write down the derivatives. And so, so of course 65 goes away, and X, you have one X, and so if this number time 2, right, times 0.03, and 2 power X this time, okay, and so you have this. Right? And so this marginal physical product is the one that is going to be equal to the ratio of prices, right? Marginal physical product is equal to ratio of prices. And so the two values that will have that equal each other is going to be this one, right? Which is the marginal physical product equals the ratio of prices, equal that one. Okay, and from there, that's it. That's all we have. And from there, we just derive x. Okay, and so this is that is the same thing. What I put in yellow over there is the same thing, right? And so so what I do here is that I keep this value here, and I'll leave the minus for now, okay? And this number is the same as this one. So I pass this on the other side of the equations, okay? When I pass it on the other side of the equations, it becomes a negative because this is plus. This is plus, and the other side it becomes minus. That's why how I have minus 1.084 here, okay? So, and then what I can do if I want to change, to make it easier for me, which I did here, okay? So I say change sign. So when I change signs, what do I get? I multiply both sides by the same sign. So if I multiply by -1, then I'm going to have, what's going on here? I'm going to have what? 0.006x, okay, equals minus 0.1 plus 1.084. Right? And so x, right, x equals 0.006. Word is having some problem here. Okay, and here I have minus 0.1 plus 1.084. And so that's what gives me this number here. And so x is equal to 164. So this is the example that is in your textbook that show how you get the optimum output. So one theory, okay, well, not in theory, one more thing that we have to talk about is that what is the optimum input allocation when the farmer has more than one enterprise. So in economics, we call enterprise basically a product that the farmer produces. So if a farmer does custom work, that is a different enterprise. If it produces corn, it's a different enterprise. And so if you produce soybean or wheat, it's a different enterprise. So within the year, right, the farmer can have access to a limited amount of loan from the bank operating loans. The bank will not give all the farmer needs. It can happen, but usually it doesn't. And so when that happens, the optimum input that we have been talking about, X, okay, the farmer may not be able to apply all the X that's necessary to maximize yield, right? So the condition is that if the farmer has different enterprises, I call those enterprises E1, those are commas, okay? Those are commas here. E1, E2, and E-net. If they are the enterprises, then the optimum allocations is the one where the value marginal products are equal, right? Okay. So if it's custom hire and production of a corn, I would say, for example, 1 hour additional hour of work or 10 additional hours of work will be equal to 10 bushels. Okay, then the farmer will allocate equal input, equal resources between the two enterprises. Now we'll go through a few applications, and in these applications we have a production function that is given to us, this one here. Okay, and a number of questions. The first question is find the x that maximizes y. And so exactly the same as before, what we are trying to do, we're trying to find the level of input that maximizes output. Then we have a data here, and we are asked to calculate the marginal physical product. Calculate the average physical product, and compute, okay, compute the elasticity of production. So those are the three questions we are going to answer here. So first, let's optimize it's a little bit slow here. Word. Let's optimize this function here, right? Okay. So here we don't have the prices. Okay, if you don't have the prices, you cannot set marginal physical product equals ratio of prices because you don't have the prices. And so what we're going to do is, this is also valid, we're going to set the marginal physical product equal to 0. So whether we set marginal physical product equal to 0, okay, or value marginal physical product equals px over py, okay, we are optimizing exactly the same way. And so again, remember to add this dy over dx, okay? So this is our value marginal product. And so from there, okay, add the dot x, and so x is this value here, right? And so we can actually compute it. 6 divided, I didn't compute it? Yeah, so it's equal to 75, okay. So x equal to 75. 6 divided by 0.08 is 75. So then we are going to compute the average physical product. And so the average physical product is just y divided by x. So we take our production function and we divide by x. And so this is the result that we obtain. So when we know that x is equal to 45, then we can determine what the average physical product is. And finally, here, well, not finally, next we are asked what is the price elasticity of production, okay? And so we have a formula. The price elasticity of productions is marginal physical product divided by average physical product. Since we have those values, okay, we know that when x equals 45, our average physical product is this, and our average marginal physical product is that, okay? And so that will be, so production is inelastic, and that's what we need, okay? Because in the optimum, in stage 2 of production. So stage 2, we want to have elasticity of productions that is between 0 and 1. Okay, and so that's what we need to be. And so elasticity below 1 say that, well, we are in the range of production. Finally, find the x that, actually I should do the same way. Find the x that optimizes profit. Okay, and so profit, find the x that maximizing profit. All right. So we know what profit is, right? Profit is revenue minus cost. But right here, we do not have information about cost. Okay. So if we want to optimize profit, we are back, okay, to our other formula here. Okay. And so we can compute the derivative of revenue. So revenue is px times x, and so the derivative of revenue over x is so px times the derivative of y with respect to x, right? Okay, so if px times the derivative of y equals the derivative of actually equals value marginal product, right? We are just taking py and we are multiplying by the so we set that to equal to value marginal product, okay, equals to input. Okay, so that's our condition. Now, if you are given the value of px and py, okay, then we can compute. Then we can obtain x. If I can move this up, then we can obtain x, right? What we do is that we substitute py value, and we substitute px value here. Okay, so py is here, px is there, okay, and we just solved for x to get the optimum here. Okay, this is it for the last video on chapter 3. I'll see you next time.